Hey guys, let's talk solving systems by substitution. When I say systems, I mean linear systems, that is, equations that would graph to be lines. So, normally, what's taught is to set up each equation in slope intercept form, graph them, and then find out where the lines intersect or cross. And that point of intersection is called a solution. So graphing is a method for solving systems, but what I want to consider is a second method called substitution. Now, normally when you substitute one thing for another, it's the idea of replacement, kind of like a substitute in a baseball game or something like that. One person goes to sit on the bench and the other person takes their place. It is really a substitution. One thing is being substituted for another. So consider this system. X plus 3 equals 2y and 2x plus 3y equals 8. So this is two equations with two things that we don't know, two unknowns, if you will. The unknowns are x and y. And so what we're looking for is a number that would go in x's location here, and the same x number would go here, and then a y that would go here and a y that would go here. And the idea is that one xy ordered pair would satisfy both equations. In other words, it would make both equations true. So whatever it is for x and for y, that would make both things true. So what we want to do is figure out what that is. What is the xy ordered pair that will make both of these true? So generally, what you want to do is look for isolating a variable. And isolation means to get something to be by itself. So when I look at this, I notice this would be hard to solve for x because there's a number in front of it. This would be relatively hard to solve for y because there's a number in front of it. This would be hard to get y by itself because it's got a number in front of it too. This one's going to be the easy one, not because it doesn't have a number, but because that's essentially 1x, right? So you're looking for the easiest variable to isolate. So in this particular case, I would say the easiest variable to isolate is going to be x in that first equation. So let me do this. So what I want to do, let's see if I can hold this camera correctly here. So I'm going to try to hold this and write at the same time. So what I want to do is take this equation, this top equation, and get x by itself. So let me write that over here, and then I'll show you what I'm going to do. It would be easy to get x by itself because I could just subtract 3 from both sides there. Now notice if I do that, if I subtract 3 from both sides, these are going to cancel, and I'm going to have x equals 2y minus 3. So what I've done there is I've taken that equation, x plus 3 equals 2y, and I've solved it for x. I've isolated x on one side. And so now what I'm going to do is rewrite this equation that says 2 times x plus 3y equals 8. But instead of that x, I'm going to substitute 2y minus 3. Now the reason I'm going to do that is because this statement says x is 2y minus 3. So x is the same thing as 2y minus 3. So if they're the same thing, it shouldn't bother anyone that I write 2 times, but instead of x, I write 2y minus 3. And then I'm going to say plus 3y right there, and that equals 8. So what I've done is I've taken two equations and two unknowns, and I've combined them to write one equation that only has one unknown, y. It has the unknown of y. So now I can solve that by distributing. So 2 times 2y is 4y. 2 times negative 3 is negative 6. And this is plus 3y right here. And then I have equals 8. And of course, 4y and 3y is 7y, which gives me that. Of course, I'm just now solving this just like I would solving equations. I mean, it is a prerequisite to be able to do this that you could solve an equation. So if you can't even solve an equation, then this is not going to make any sense to you. But Hopefully you're following here and you can solve an equation. Notice I added 6 to both sides, got this. That means if I divide by 7 here, I'm going to see that y is 2. 2. It's kind of hard to write with one hand, so y is 2. So that means y is 2 in this problem. So that's one of my answers. In fact, that's my answer for y. Now, if I come back up here and I put that in right here, if I put that 2 in right there for y, I see that that's 2 times 2, which is 4. So this becomes x plus 3 equals 4. So I put that 2, y is 2, I put it in right there, 2 times 2 is 4, so this becomes x plus 3 equals 4. So what number plus 3 equals 4? Well, 1. So x equals 1. So what I'm saying is the ordered pair 1, 2 is the xy value that when you put it in this original statement up here, put 1 in there, put 2 in there, put 1 in there, put 2 in there, it makes both statements true. That's what it means to solve a system of linear equations. Hey, this is solving systems of linear equations by substitution, and the answer for this particular system was the ordered pair 1, 2. X is 1, y is 2. And so that is substitution. Bye.